Hi, this is the first lecture in a series of lectures for analytical chemistry, quantitative chemical analysis. And these lectures, including this first one, are based on the textbook Quantitative Chemical Analysis written by Harris. This first chapter, which is maybe an illegitimate chapter in a sense because it's labeled Chapter 0, really just gets us into thinking about what it is to be an analytical chemist and what the subject of analytical chemistry is all about. So we're going to talk through that a little bit here, and then I'm going to have a chance for you to, I'm going to leave some space on the slides and have a chance for you to do a little bit of thinking and reflecting about each of the different topics, and ask you to come to class next time having written down some thoughts or some examples that we can share in small groups. So let's get started. So we've got these key learning objectives. It's pretty straightforward. There will be some terms that we learn, and I think you should be able to discuss the topics and also give some examples. So what is analytical chemistry? Well, wow, that really didn't do what I wanted it to do, but let's start here. So analytical chemistry, we have two different types of analysis that can be done, and those are broken down into the two categories: quantitative chemical analysis and qualitative chemical analysis. And as it turns out, quantitative chemical analysis is the measurement of the quantity, or how much of a chemical there is in a given sample. Sometimes these are very small samples, very small concentrations, sometimes they're very large. But needless to say, we're measuring the quantity of something. Qualitative chemical analysis, on the other hand, is the identification of an unknown chemical. So what is its identity? What type of chemical is it? What's its name? What's its formula and potentially a structure of it? And very distinctly different types of analysis that we'll do, though both of them are contained under the umbrella of analytical chemistry. This semester in Chem 1, we're going to be almost exclusively concerned with the first of these, the quantitative chemical analysis. And then qualitative comes into play when we get into Chem 2, though they're very distinctly different, and so we'll talk more about that later. So where are they used? Well, as it turns out, analytical chemistry is really thoroughly embedded into nearly all of the other areas of chemistry. So we can think about general chemistry, which is a general overview of all of the other areas, including organic and a little bit of bio and a little bit of physical chemistry, a little bit of inorganic. And we're going to be using the quantitative techniques and qualitative techniques at times in all of those various areas, but really it's analytical chemistry that's embedded within these other topics of chemistry. So what you'll find going forward is that if you haven't taken organic, if you haven't taken physical chemistry or biochemistry, that the techniques and the methods that we learn about are going to be things that'll be really helpful for you. If you have taken some of those courses, you're going to be relearning some of those techniques, or you're going to be remembering that you've used some of these methodologies already. So it's going to really relate well to those topics. Okay, so what do we have next? The general steps in the analytical process are really what the entire Chapter 0 is about. And it's distinctly separate from the scientific method, though you'll see that it overlaps that nicely. And so we begin by formulating a question. So we're not going to talk about a hypothesis. As it turns out, when we're doing science, we don't often formally sit down and write out a hypothesis in chemistry. But we do have to address what specific question is being examined. And this is important because in order to arrive at an answer, we need to know what types of responses, what types of answers would actually provide sufficient justification to move on from a question or to produce some sort of informed conclusions about it. So what specific question is being examined? Oftentimes this will take a number of different forms, but an example of it might be what is the effect of heating, that is thermal heating, on fresh natural gas soot particles or diesel soot particles or something like that. And so a simple question, you want to know what happens when you do something to a sample, that would be the sort of question that you could ask. I'm going to leave some space below each of these. I don't want you to currently write an example. At the end, I'm going to ask you to reflect on all of the different steps in the analytical process and come up with some sort of experiment that one could do or that you have done and fit the different portions of it into each of these to just process this further. So the next step is selecting the analytical procedure. And this is where we use personal knowledge, maybe colleagues and their knowledge, literature review of journal articles, textbooks, other things that we can read to find the procedures and instruments that can give the desired information. It's important at this point to understand the specific question, because if we don't know the question, how can we understand what types of answers we're trying to get? So if we clearly define one, then we can move on to the second step and select a procedure. It might be a laboratory procedure, it may not. Maybe there's already information out there. But nonetheless, this is the second step, selecting an analytical procedure. Mostly has been done for you in laboratory settings, but this semester we're going to get some really good experiences having to figure out our own procedures, adapt procedures that maybe aren't appropriate for what we're actually trying to do, and talk about that as a class so we develop skills in doing so. Next is sampling. So we've got a question, we've got a procedure, but now we need to collect samples. And we need these samples to be samples that represent the whole of the material that we're asking the question about. So if we have a heterogeneous material, we need to make sure that we're getting different portions of that heterogeneous material. If it's homogeneous, it might be easier. We need to ask questions about how many samples do we need to collect to ensure that we have a representative sampling of the whole. Sometimes it's 1, sometimes it's 2, 3, 10, 100. Maybe thousands of samples need to be collected. And so there's questions that go into sampling as far as the number and where or when to sample. How do we do that? Once we have those samples, however, that's not the end. We've maybe collected a sample, but we need to move on. We need to get it ready to follow up that collection with some sort of technique. And so that's sample preparation. This is the process of converting the representative samples into something that is suitable for chemical analysis. It must reflect the type of chemical analysis that we intend to do, and it must also keep in mind that we want to maintain the integrity of the samples we've collected. So we're not looking to use sample preparation techniques that are going to affect our samples, aside from produce samples that are now capable of being analyzed using our procedure. Some examples for this would be dissolving, masking, or crushing. So sometimes we dissolve something and it might change it in a way. Maybe there's a chemical reaction that takes place there. But if it's truly just dissolution, we still have that chemical present and it can be monitored or measured. Same thing with masking and crushing. The next step here is chemical analysis, and in chemical analysis, this is the process of measuring the concentration of analyte in the representative samples in several identical aliquots. And so the important part here is not so much what we're actually doing. It's probably pretty straightforward for you to understand that, yeah, we're going to take a measurement using the procedure we've identified, and we're going to do that with the representative samples that we've chosen and then prepared for the method. The important part here is understanding that in most cases, in order to get enough data to represent a good conclusion, which we'll learn about when we talk about statistics, what our measures of that validation are, we want to make sure that we're doing it in several identical aliquots and that we might be repeating that measurement over and over and over to get 10 or 20 or 30 different measurements. We're going to do this a lot this semester in lab. You're going to be working as an entire class to collect sufficient data at times to be able to conduct some statistical analysis on it and that will result in some certainty in our results. So that's something to keep in mind. Finally, after you've collected this, you're going to report it. And so we're going to be delivering that information clearly. It's going to be written, it's going to be in data tables, it's going to be in graphs and plots, and it should include information about the limitations of that. So if we've seen that there's statistical information that suggests certain data points might not be valid, or there's a range that's invalid where there's a range that is valid, those are the sorts of things we want to include. But we also have to keep in mind that this report needs to be written for the intended audience. Now for our course, the intended audience is me, your professor, but in other cases, it might be your boss, it might be your mother, it might be a group of other analytical chemists who are going to be at a conference that you're going to be reporting at. It might be a government agency. So you can see that there's a wide range of people, and the way that we choose to report the data is going to be very, very different. For instance, if you were asked, as a result of having done some experiment in the lab, if you were told, you know, we'd really like to hear your perspective, you're a Christian, you do this chemistry, we'd like to hear your perspective of how a Christian does chemistry in a laboratory in a Sunday school class where we're exploring the ideas of the intersection of faith and science. You would present that information to those people in a much different way than you might present to me or that you might report in a journal article. So just keep that in mind. Finally, we interpret the results. it's important to know that as we're drawing conclusions here using the results that we collected, that it might not be done by the chemist or the analyst that actually collected the data. Oftentimes this is done by government officials, by congressmen, by governors, by bosses that might have degrees in business, not in chemistry. And so if we've done our due diligence to get to the point where we've reported the data, we've reported the limitations, we've reported the statistical information to show what's valid and what's not valid, we need to be willing to hand it over and allow other people to make those conclusions. And then when they have questions, we need to be prepared to answer them. But this part is oftentimes not carried out by the original analyst. So what we come to here is a brief statement about analytical chemistry. I'm going to read that for you, and then I'm going to describe a little bit more detail than what I did previously, what I want you to do for class next time. So analytical chemists are concerned with conducting chemical analysis in accurate and precise ways that are reproducible and exhibit clear and understandable limitations. This is a nice statement that really embodies what we're going to be doing this semester. There's a reason that the word analytical starts with anal. We're going to be very careful and meticulous, and so that's something that for some of you is going to be a great joy, and for others of you, you're going to struggle with that. But just to warn you, that's where we're going to be coming from. What I want you to do now is I want you to, in preparation for what will be a 2-minute review or a 2-minute summary of this, I want you to go back and write down an example under each of these steps of the analytical process. Something that comes from your experience, something that you dream up. Maybe you just come up with something that you're thinking about and you want to see how that would be carried out and what might be possible with it. I want you to come up with some examples. You might not have something great in each one of these. What we're going to do is we're going to share them in small groups, share them as a class, talk through it in class, and it's going to give all of us an opportunity to just really more clearly see how this plays out. From here, we'll move on to Chapter 1, which is all about measurement techniques. We're going to be doing measurement in lab this first week of class, and so we're going to get to interact with this pretty extensively. I'll see you in class.